This is 9.4 notes. I'm going to do both day 1 and day 2 in the same video. So if you are here for day 1, you will stop after I'm finished with part 1. And if you're here for day 2, just skip ahead to the second set. Part 1 is I'm going to be exponential equations. So to solve an exponential equation, when I'm given x equals a to the y power, how do I solve for my exponent? What we do first is we isolate the exponential expression. So if there's something being added, subtracted, multiplied, or divided on our exponential expression, we need to use algebra to get that alone. Then we are going to rewrite the equation in log form. Here it is written here if you have forgotten how to do that. Or we're going to take the log of each side using our inverse property, and we're solving for our variable. So the inverse property would be that if log base a of a to the x power is going to be equal to x, whatever that exponent is. And then the same is true for our natural base of e. If we have natural log of e to the x, that is going to give us x. So let's jump into some examples. On example 1, I have 2 to the x power equals 32. My exponential expression is already isolated, so there's nothing I need to do. So now what I'm going to do is rewrite this expression in log form. So log base 2 of 32 is equal to x. Now I know that this is 5, so that means that x is 5. But that's not always going to be the case. And so if we go on to example 2, again, the first thing we need to do is isolate our exponential. So our exponential expression is 2 to the x. So what I need to do first is divide by 3 on both sides. And so I end up with 2 to the x power is equal to 14. Now, if I rewrite this as a log, that would be log base 2 of 14 is equal to x. Now, I don't know what log base 2 of 14 is right off the top of my head, so I need to use my calculator. So, again, we can use that change of base formula we learned earlier, so we could do log of 14 divided by log of 2, or I'm going to be showing you a new trick. If you go to math and scroll all the way down to alpha A for log base, you can switch that to log base 2 of 14. And we find that x is, and we're just going to be rounding here, about 3.807. So 2 to the 3.807 power gives us 14. Okay. On to another example. 4 times e to the 2x power equals 5. So again, first thing I need to do is isolate my exponential expression. In this case, it is base e, so we're going to divide by 4 on both sides. And so we get that e to the 2x power is equal to 5 over 4. Now we could rewrite this as in log form, or we can take the log of both sides, which is what I'm going to do to show you both ways. So if I take the log, if my base is e, this is going to be natural log. So natural log of e to the 2x is equal to natural log of 5 over 4. Now this is where we're going to use that inverse property. Natural log of e to the 2x, that means that natural log of e to the 2x is 2x, and that's going to be equivalent to the natural log of 5 over 4. So I can find what natural log of 5 over 4 is in my calculator. And so we find that 2x is about 0.223. And if I divide that by 2, we find that x is approximately 0.112. All right, on to 4. 3 to the x plus 4 power equals 6. So my exponential is already written by itself, so I'm going to take the log of both sides, and 3 is going to be my base because that is what is being raised to the power in my exponential expression. So log base 3 of 6, I'm sorry, I'm not writing it in log form. I'm taking the log of both sides, pardon me. Log base 3 of 3 to the x plus 4 is equal to log base 3 of 6. So again, inverse property, log base 3 of 3 to the x plus 4 is x plus 4. And so that gives me log base 3 of 6. So I'm going to type this into my calculator. Again, going to math, scroll down to option A, log base 3 of 6. Hold on. I didn't mean to put that plus sign there. All right. So x plus 4 is 1.631. And if I subtract 4 from that, I find that x is approximately 2.369. Sorry, negative 2.369. All right, and on to 5. 23 minus 5 e to the x plus 1 is equal to 3. So again, I need to isolate my exponential, so we subtract 23 on both sides. So negative 5 e to the x plus 1 is equal to negative 20. And then I divide by negative 5. And e to the x plus 1 is equal to 4. Now what I'm going to do is write this in log form, just so you can, again, see both methods. And we are going to be using natural log here. So natural log of 4 is equal to x plus 1. So I can put natural log of 4 into my calculator. So 1.386 is equal to x plus 1. If I subtract 1 on both sides, I'm going to find that x is about 0.386. And that is it for day 1. That is just solving the exponential equations. Moving on to part 2, which is logarithmic equations. So this is where it's the opposite of what we just did. We are solving the logs. So we can use our properties of logs. Again, if we have log base a of x is equal to log base a of y, that means x is equal to y. Or we can use our inverse property. A raised to the log base a of x power is going to give us x, and the same is true for our natural base. So what we're going to do to solve these is isolate our log expression just like we did with the exponentials. If we have something being added, subtracted, multiplied, we are going to get rid of that using algebra, and we might need to condense our log first, and then we are going to write it in exponential form or exponentiate both sides, which is our inverse property, and then solve for our variable. So starting here with number 1, I have 2 times log base 5 of 3x equals 4. So what I want to do first is isolate my log, so I'm going to divide that 2. And so now I have log base 5 of 3x is equal to 2. So I can now write this in exponential form. So remember, my base is 5, so that means 5 squared is equal to 3x. 5 squared is 25, and if that's equal to 3x, we're just going to divide on both sides. And so x is approximately 8.333, repeating, 25 over 3. Okay. Not too bad. Moving on to another example. On the back, number 2, I've got several logs here. So what I need to do first is condense this. So I've got natural log of x minus 2 plus natural log of 2x minus 3. So remember our log properties, that means that these can be multiplied. So that's going to be natural log of x minus 2 times 2x minus 3 is equal to 2 times the natural log of x. Now, this log on the other side, I can also condense using my exponent property. So that's going to give me natural log of x squared. And I can now move it to the other side. So natural log of x minus 2 times 2x minus 3 minus natural log of x squared is equal to 0. And look, this is now subtraction. So to make this one log, here is going to be my final logarithm, and that is equal to 0. So how do I solve for x? What I'm going to do now is rewrite this as an exponential equation. So natural log, that means base e. So e to the 0 power is equal to x minus 2 times 2x minus 3 over x squared. Well, what is e to the 0 power? That's 1. And spoiler alert, this one is going to be a quadratic if you haven't picked up on that already. So 1 is equal to this whole big thing on the right. So the first thing I need to do is get rid of my denominator, and I'll multiply by x squared. And then I'm going to go ahead and FOIL the top. So x minus 2 times 2x minus 3, and that is going to give me 2x squared minus 7x plus 6. And now I can move that x squared back over. So x squared minus 7x plus 6, we can factor that. It's going to give us x minus 6 times x minus 1. And so our two solutions are x is 1 or 6. All right, number 3, 1 minus 2 times the natural log of x equals negative 4. So I first want to isolate my log, so I'm going to subtract 1. So negative 2 times the natural log of x is equal to negative 5. And now I can divide by that negative 2. And so the natural log of x is equal to 5 over 2. So now I'm ready to write this as an exponential. My natural log base is e, so e to the 5 over 2 power is equal to x. And I can type that into my calculator. E to the 5 over 2 power, and we find that x is about 12.182. And last but not least, number 4, we've got log base 6 of x plus log base 6 of x minus 5 is equal to 2. So the first thing I want to do is combine that into a single log. They're being added, so that's my multiplication property. So that's going to be log base 6 of x times x minus 5 is equal to 2. So I am now ready to write this as an exponential. So that's going to be 6 squared is equal to x times x minus 5. So 36 is equal to x squared minus 25x. Sorry, not 25x, that would just be 5x. Don't know where my head is at. All right, and I'm going to move everything to the same side. And I can factor this. That is going to give us x minus 9 times x plus 4. And so our two solutions are x could be 9 or negative 4. And that is it for both day 1 and day 2 of our 9.4 notes. We have now looked at exponential equations and logarithmic equations.